Hey students, today's video is going to be on multiplying integers, and we're also going to go ahead and do dividing integers as well. So to start with multiplication, we're going to do some examples where we're multiplying integers that have the same sign. So here we have -5 times -6. And we sort of talked about the rules to this already, where when we multiply a negative times a negative, we're going to get a positive. So this is going to be positive 30. And then when we multiply 5 times 6, that's also going to be positive 30. So both of those problems are going to simplify to 30. So let's go ahead and write down a general rule that when multiplying two integers with the same sign, the product is always positive. Multiplying two negative integers or two positive integers will result in a positive product. Now let's do some integers with different signs. So here we have 3 times -4, that would be -12, and -7 times 4 is -28. So, as a general rule, when multiplying two integers with different signs, the product is always negative. Positive times negative or negative times positive, the product will be negative. Now let's do some examples with exponents. We have to pay really close attention to the parentheses when we do exponents problems because we need to pay attention to what is the base of the exponent. So here we have -2 taken to the second power. So those parentheses around here are telling us we're multiplying -2 times -2. And -2 times -2 would be positive 4. This next example, -5 squared, is a little bit different. There's no parentheses around the -5. So I could kind of put parentheses around like this to show you what we're really saying is 5 squared, and then we'll take the negative of that. So if there's no parentheses, it's kind of implied that all you're squaring is the 5, not the -5. So we're going to say negative, or opposite, of 5 times 5. 5 times 5 is positive 25, but we're going to take the opposite, so that's -25. So you can see this example resulted in a positive integer because we're multiplying a negative times a negative. This example results in a negative integer because we're taking the opposite of a positive times a positive. So there's a difference there. Let's look at this last example. We see the parentheses are telling us what we're cubing is the -4. Okay, so I have -4 times -4 times -4. Let's start with the first two integers. -4 times -4 is positive 16. And positive 16 times -4 is going to result in negative. And let's think here, 10 times 4 is 40, 6 times 4 is 24, so that would be -64. Now let's look at an example of a real-life application. So here we have this bar graph showing the number of taxis a company has in service. We don't have a number here, so we don't exactly know how many we started with, but we can see from the graph that the number of taxis decreases by the same amount each year, and that amount is 50. So it's going down by 50 every year for 4 years. So let's think of what we're really multiplying here. Down by 50, the integer would be not positive 50, but -50. And then that change is going to be -50 times 4 years. So, oops, there we go. So the total change is going to be the change per year times the number of years. So that would be -50 times 4, which is -200. So in this 4-year span, the taxis have decreased by 200 taxis. All right, let's go ahead and talk division because it's the same rules. Here we have dividing integers with the same sign. Just like negative times negative is positive, negative divided by negative is positive too. So negative 18 divided by negative 6 will be a positive 3. And positive divided by positive, we know, is positive as well. So as a general rule, when dividing two integers with the same sign, the quotient is positive. Pause and get that down. Let's do integers with different signs. When we're dividing, same rule as multiplication. Positive divided by negative will be a negative integer. So in this case, negative 3. Negative divided by positive, same thing. That's going to be negative 9 in this case. So as a general rule, when dividing two integers with different signs, the quotient is always negative. Let's do some examples where we're evaluating an expression. Here we have the expression 10 minus x squared divided by y. And we want to do that when x equals 8 and y equals negative 8. So we're going to substitute 8 for x and negative 8 for y, and we'll just rewrite this expression. So 10 minus 8 squared divided by negative 8. And I usually put my negative numbers in parentheses when it's next to another operation so that we don't get confused here. We're dividing by negative 8. We're not subtracting 8. And then let's think about our order of operations. We're going to do exponents before we would do multiplication and division. So we'll say 10 minus 64 divided by negative 8. And then we're going to do our division before our subtraction. So we'll do 64. I'm going to fix that. That's looking weird. All right. That's better. Okay, so 64 divided by negative 8 will be negative 8. So we have 10 minus negative 8. We can rewrite that as 10 plus 8, which is 18. All right, one last example. We have another real-life application. So we measured the height of the tide using support beams of the pier. So here we see these support beams. Your measurements are shown in the picture. So at 2 p.m., we're at 59 inches, and then by 8 p.m., we're all the way down to 8 inches. What is the mean hourly change in the height? So it's gone down a certain amount over 6 hours, right? So we want to know how much did it go down each hour. So here we're going to say the mean hourly change is the final height minus the initial height, so how much it's changed, all over the elapsed time. So in this case, we're going to say 8 minus 59 over the elapsed time is 6 hours. Okay, all we need to do is simplify that. 8 minus 59 is going to be negative 51 over 6. And then we can go ahead and simplify that. That would be, let's see, 8 hours and 3 over 6, so 8.5 inches per hour. All right, so go ahead and try the on your own, and I will see you soon.